High Vacuum Technology Course. Week 9. Paul Nash. He's Subject Leader, Engineering. Vacuum Technology Recap on last session. Progress on assignments to date. MateCam 097SS01.ppt, Gas and Vapor Load Leakage Outgassing Residual Gas. Process Load, Vapor, Trapped Volumes etc. Backstreaming. To Pumping System. Gas and Vapor Load. Vapor pressure of materials used must be much less than the required ultimate pressure. Surfaces should produce minimum outgassing by being cleaned and preferably polished to reduce surface area. Surfaces should not be affected by exposure to atmosphere, rust etc. Outgassing. The spontaneous evolution of gas from a material becomes a significant factor as pressure reduces. The outgassing rate is the quantity of gas given off per unit time by every unit of surface area in the system. Usually expressed as mbar liters per second per square centimeter mbar ls 1 centimeter minus 2. Outgassing total gas load PULT equals ultimate pressure SP equals pump speed. Q equals outgassing rate of material 1, 2 etc. I equals area of material 1, 2 etc. UHV system design. Eliminate materials that cannot be baked. Use clean techniques, gloves, clean atmosphere. Stainless steel is popular. Low outgassing. Doesn't readily corrode. Can be baked to 750 occ. Baking typical bake-out temperatures between 250 occ and 450 occ. Maximum baking temperature may be limited by materials. All components should be baked to similar temperatures. Gases will transfer from hot areas to cooler areas. Leak detection. Origin of leaks. Types of leak rate. Virtual leaks. Leak detection methods. This activity presents fundamental information on vacuum. The principles of vacuum are related to a basic set of properties that relate to gases. Some of the processes that take place in the top-down nanomanufacturing environment require vacuum conditions in order to proceed correctly or to avoid contamination. The measurement of the level of vacuum present in the process is important, as the levels required vary for each type of process. To be able to understand the various concepts involved with vacuum technology, it is important that the basic concepts of vacuum and its associated terminology be discussed. The Vacuum Fundamentals module covers the basic concepts of pressure, gas laws, and gas characteristics. These topics are fundamental to the understanding of vacuum systems. MateCam 097SS01.ppt. Leak detection. Leak and leak detection. Origin of leaks. Poorly connected or unconnected fittings. Permeation through walls. Holes. Leak rate. Single gross leaks. Gross cumulative leaks. Large leaks, often caused by poor connection of parts, missing seals etc. may even be possible to hear the leak. Gross cumulative leaks. The sum effect of several moderate leaks, resulting in the same symptoms as a single gross leak. Leak rate. Small single or multiple small leaks may allow the system to be pumped down but not attain ultimate vacuum. Faulty components. Poor surface finishes on mating surfaces. Thin permeable walls. Leak rate. Small single or multiple small leaks may allow the system to be pumped down but not attain ultimate vacuum. Faulty components. Poor surface finishes on mating surfaces. Thin permeable walls. Leak rate units are mbar s for example. Gas enters the system at a rate proportional to the external pressure and varies with the molecular weight of the gas. For example, the molecular weight of air is approximately 29 whilst that of helium is 4. Therefore helium will flow through a system faster than air. For a high vacuum system, the leak rates given below. QL less than 10 to 6 mbar middle.L/S, very tight system. QL less than 10 to 5 mbar middle.L/S, tight system, and QL less than 10 to 4 mbar middle.L/S, leaky system. The aims of a leak search equals greater than localize a leak and or to determine leak rate. Virtual leaks, symptoms of leakage but no real leak. Outgassing, e.g., trapped pockets of gas in the base of blind holes, problems that appear to be leaks. Outgassing. Leaks. Virtual. Real. Backstreaming. Diffusion. Permeation. In practice, it is impossible to build a completely leak-tight vacuum system. The leak rate must be small enough not to prevent to reach the required pressure level. Without active pumping, the pressure in a real system will rise with time. Pressure rise is produced by outgassing and by gas molecules penetrating through leaks from the outside into the vacuum system. A real leak will yield a linear pressure rate of rise curve. The slope of the curve is a function of the leak rate and the volume of the system. The larger the leak, the steeper the slope. The larger the volume, the shallower the slope. MateCam 097SS01.ppt. Tracer gas helium leak detection. The tracer gas should have the following properties. Clear signal in the mass spectrum of the residual gas. Chemically and physically inert, non-explosive and cheap. Very low content in air and easily removable by pumping and not contaminating the system. He is most commonly used. The small diameter of He atoms allows the detection of very small leaks. The leak rate is usually given as He standard leak rate, He standard. As the speed of He is 3 times higher than the speed of air, the amount of helium entering through a leak and thus the sensitivity is increased by a factor of 3 compared to air. Leak detection methods. Mass spectrometer leak detection. Searches for evidence of a trace gas introduced into the system. Thermal conductivity methods. Based on the difference in thermal conductivity between a search gas and air. Helium leak detectors. In principle, any type of residual gas analyzer can be used as mass spectrometer helium leak detector. The most sensitive and safe device, however, is a mass spectrometer with 180 degrees magnetic sector field optimized for the detection of mass 4. The ions are accelerated into a magnetic field, where they are deflected. A system of slits allows only He ions to pass to a collector unit located at a deviation of 180 degrees. To detect tiny leaks, the currents to be measured are extremely small. At the highest sensitivity of 10 to 12 mbar middle.L/s, currents as low as 10 to 15 may have to be measured. http://www.youtube.com/watch v = loco6jh0a3u. Helium leak detection. For leaks, searching vacuum vessel is continuously evacuated. The tracer gas penetrating from the outside into the system is pumped through a leak detector where its concentration is measured. For leak location, the tracer gas is sprayed locally, while for total leakage measurement, the vacuum vessel is completely enclosed by the tracer gas. Leak location measurement. Total leakage measurement. Detector method for pressurized systems. The device to be investigated is pressurized with He. For leak location, a sniffer probe is connected to a conventional helium leak detector by a capillary tube or needle valve. The detection limit of the sniffer method of about 10 to 7 mbar middle.L/s and is determined by the natural He content of air. For total leakage measurement, the vessel is placed into an evacuated test chamber with detector unit. Leak detection of pressure vessels. Leak location using a sniffer. Total leakage measurement. Calibrating leak detectors. Calibrated leaks. Helium escapes at a known constant rate by permeation through a quartz membrane. Leak testing sealed packages. Helium leak testing of sealed packages was resolved using the bombing helium leak testing. The method involves several phases. 1. Helium pressurization equals greater than placing a sealed package in a chamber where it will get pressurized with helium. Given the pressure differential between the outside and the inside of the part, helium will be forced inside the part, through the crack, during the time of pressurization. Helium will eventually fill the part over time. Leak testing sealed packages. 3. The part is placed inside a test chamber that is connected to a helium leak detector, HLD. In case of a leaker, the helium that was forced in the part will come out through the crack. The HLD will detect and measure the helium leak rate coming out of the part. 2. Removing the part from the pressurization chamber and bringing it to the HLD. The greater the internal volume, the longer the pressurization time. Practical limitations of the leak test method. There are 3 physical limits to this leak test method. The internal dead volume of the part. If the latter is too small, it cannot keep a sufficient quantity of helium that can be detected. 2. The sensitivity of the LD cannot accommodate the measurement of ultra-small leaks. 3. Parts that have a huge leak and that get pumped out during the pump down phase of the leak test. Helium gets removed before the LD can detect it. Such leaks require a different leak test method to be caught, such as visual tests.